Welcome back, class. Thanks for tuning in. We're going to jump right in here. We're in week 9, part 1. This is our last week before summer break. So, again, thank you for all those who are actively participating in each of these learning opportunities I've been sending out. I know a lot of you have been doing some stuff to make up grade and make up homework that we haven't completed or maybe just got low scores on. So, thank you for that. They're all due tomorrow. Or, not tomorrow, Wednesday. Jeez, I'm way off. Let's kind of go through our lesson today. We are going to be graphing again, but a little bit slight differentiation here. There's a couple different topics we have to talk about with this graphing. Let me jump to my iPad here so you can see what I'm talking about. Okay, so on my iPad screen, what you're looking at here is we're doing equations for lines, and the idea is that the lines we're going to be doing today will be either a solid line like this, or it will be a dashed line. And I'll show you the difference, like when you know it's a dash versus a solid. And I mean a dash like there's actually breaks in the line, where it's not like used. But then what we're doing is we're going to be shading a certain part of the graph. So what I mean by that is that maybe all the answers that work on this particular formula will be below the graph. So I can shade in half the graph. So it's half planar. Plane is the thing that I'm drawing on. It's a coordinate plane. We can shade in half of it, the part below the line, and I can get right up infinitely close without crossing over it. That's the idea. That's what we're doing. So these are called inequalities. We're graphing inequalities. Now we're still doing the same concepts. We're still doing slope. We're still doing y-intercepts. We're doing slope-intercept form or other forms. That's why I have them all printed here. But we prefer slope-intercept. This is the go-to version for how we graph. It uses a y-intercept where it hits the y-axis and a slope, how it's going up and to the right or down to the right, that type of idea. And we're going to be graphing. So I'm going to show you the shortcuts. I got 3 problems picked out here, kind of a range of difficulty. The first one is based on the easiest one that we can do, and then the other ones will be a little more challenging. I'm going to show you my way of doing this. This is probably different than how Mrs. Weisenstein or any other math instructor would show you. I think this is kind of the easiest way. This is the way that I always approach it. There's other methods. It's just this is the one that I always kind of go to, and I think it's the best way to do it. Okay, so let's jump right in here. Okay, so what you're looking at here is an equation, right? It's in y equals mx plus b form. Whoa. Apologies. So it's in y equals mx plus b form. That's slope-intercept form, if you don't know. That's slope-intercept. That's the one we did, I think, a couple weeks ago. Slope-intercept. So now, why they come up with this, it's not real creative. The m is your slope, and the y-intercept is the b number. So my slope is 2. We'll make that a fraction. It's 2 over 1. And then this is my y-intercept number. It's the negative 1 in the back. So that means I'm hitting negative 1 on the y-axis. That's what a y-intercept is. It's a y-intercept. It's the y-axis. And then the slope is going 2 over 1. So my slope, which is m, that is 2 over 1. Now, this is a whole number, so I made it a fraction by putting the 1 on the bottom. So that means from this dot that I have drawn, I can go up 2 over 1, up 2 over 1, up 2 over 1. How I know I'm going up to the right is because it's a positive slope. It's positive 2 over 1. All right, and then I'm going to draw the line. Now, I was talking about earlier, is it a solid line or a dashed line? This thing tells me it right here. This item, this inequality symbol, it's not an equal sign, if you can tell. It's a less than or equal to symbol. How I read that, if that little like arrow is pointing to the left, it's a less than symbol. If it's pointing to the right, it's a greater than symbol. That's just how you read it. So this is a less than or equal to, because that's what the little bar means. If the bar is below it, like this little like bar underneath the little Pac-Man symbol, the inequality, then you have a solid line connecting these dots, like this. It is a solid line passing through each of those dots. If it was just the inequality symbol and no line underneath it, no little bar, then you'd have a dashed line connecting all the little circles. So it's including the line versus not including the line. Okay, hopefully that makes sense. That's this first step. Now, what we're going to be doing next is figuring out what part of this graph we're going to be shading. Now, why we do that is because the inequality symbol. There's an infinite number of answers that could work, because I only have to be greater than or less than this particular equation because of the inequality symbol. It's not an equal sign. It's not just one number on the line itself. It could be anything around it. That's what the inequality symbols mean. How I figure out which side to graph, it's not guessing. It's picking a coordinate that is off of the line first. I just have to pick one, and I'm going to check to see if it works. So I'll explain that here in a second, but I need to pick one first. So the dot I'm going to pick, and I'm going to pick it so it's clearly way off of the line. I'm going to pick 1, 2, 3, 4, 5, and up 1. Okay, so 5, comma 1. I'm picking that dot because it is clearly way off of the line itself. So that's the dot I'm going to pick. You can pick any dot you want. I just have to pick the coordinate, and you have to have the coordinate written down. So I'm going to be checking 5, comma 1. This is my x. This is my y. I want to check, does that dot also work in my formula? That's what I need to check. If it does, that's the side that I shade. If it doesn't work, that means none of the dots around it will work, so the other side of the line must be the answers. So it's kind of like a check. This side or that side, that's what we're checking for. I'm checking the side with the 5, comma 1. So how you check this? I'm going to go back to my original equation. Let me erase all this stuff we have here. I'm going to check by plugging in 5, comma 1 into that equation. The x is the 5. X is the 5. And the y is the 1. So I plugged in the 5 and 1 into the actual formula where the x and the y are located. So you're substituting, if you will. So 2 times 5 is 10. And I'm going to subtract 1. And I saw the less than or equal to symbol. The 1 is still over there. Okay, so now what we do is we check. We check this statement. Is 1 less than or equal to 9? Is that true? Is 1 less than or equal to 9? Yes. That is true. It is a true statement. 1 is less than 9. It could be or equal to, but it is less than 9. That is true. That means the dot I chose, just at random, that dot worked. 5, comma 1. It made this statement a true statement. That means all the dots around it would also make it a true statement. So that means I need to use all the dots on that side. So I'm going to shade all the graph that is over here, because all these dots, I could have picked any dots over here and they would have also have worked. So I'm just shading them all in, and you just color in half the graph. Notice I'm not going to the other side of the line. Any of the coordinates over there would not work. It would make a false statement. So if I picked any of the dots like over here, that would not work. It would make a false statement. Like the left side would be, it wouldn't be less than the right side. So that's what's happening. Hopefully that makes sense. Now, this is what we're doing for each of the 3 problems. So I think on the Google form that I sent out, I think there's 4, I think, in there. But these are the next couple problems will range in difficulty. Now, the reason why, they're not all going to look like this one. They're not written in the right form. It's not y equals mx plus b. If it's in that form, these problems are super easy, like you saw here. If they're not, we have to rearrange it a little bit. All right, so let me go to the next problem. We have 2 problems left. So as you can tell, this thing is definitely not in the right form. It's got the y, the minus x, not written in the right form. I'm going to rearrange this thing. So what I mean by that, I'm going to move this x to the other side. I'm going to add the x over, so it'll be like this. I'm going to leave this symbol alone. I'm going to add the x over. That is a 1x, technically. I'm going to add it to the other side, so it's a positive. And then the 6 is currently already sitting over there. It's a positive 6. So I'm adding the 1x to the 6. And then I'm going to get rid of the 2. So I'm going to divide everything by 2 here. So divide everything by 2. So the 2's up here cancel out. So it's just y. And then this is 1/2 x. And then the 6 divided by 2 is 3. Now, this problem looks like the last problem I just did. It is almost the exact same type of problem. I'm going to go graph it. I'm going to try to figure out what side of the line I need to shade, if the line is solid or not. I can tell you by just looking at this graph, it'll be a solid line that I'll draw because it has a little bar underneath it. That's the idea. So let's go ahead and solve this out. Or graph this out, I should say. Let me put it in red. So the first dot, the y-intercept is 3, because this is the y equals mx plus b. This is the formula that's kind of representing its slope-intercept form. So the b is the 3, so I'm hitting the y-axis at 3. That's my y-intercept. Y-int, if you will, if I abbreviate. This is my slope, is the little m. So it's the 1/2, so I'm rising and running. That's what slope stands for. So from this dot, I'm going to rise 1, run 2, Rise 1, run 2, rise 1, run 2. You get the idea. Rise 1, run 2. Okay, and now I'm going to draw the line that connects them. And the line, like I said earlier, it is a solid line because the little bar underneath it. So the bar's underneath it, solid. Now I got to figure out what side of the graph to draw, which one to shade in. So just like I did earlier, I'm just going to pick a dot. I'm going to pick the same dot I did earlier. I'm going to pick 5, 1. 1, 2, 3, 4, 5, 1. Now again, why I'm picking that dot, it's just random. It's off the line. It's clearly off the line. That's what I'm going to choose. Okay? So 5, 1. All right. So let's go back to this problem right here. We'll get rid of all these little marks here. All right. There we go. Let's get rid of all these little marks. All right. Harder than it looks to erase all these. Missing all these marks. Okay, so I'm going to plug in the 5, 1 into this formula. So the 5 is the x, and the 1 is the y. And I just need to check, is this true or not? So 5 times half is 2.5, so 5 cut in half basically. Add the 3 to it. Is that number greater than or equal to 1? Yeah, well, duh, this is 5.5. That is most definitely greater than or equal to 1. 1 is smaller than 5.5, so that is true. So that means all the dots over here are going to work. So I'm going to shade this half of the graph. There you go. Again, I get right up to that line where that line's going. I don't want to go on the other side of it. Okay, there's the second problem. Third problem, same exact idea. I'm going to give you a line. We have to go graph it, figure out if it's a solid line or not, figure out what side to shade. So half planar. Okay, so in this one, I need to get y equals mx plus b. So I'm going to move the 2 over. I'm going to subtract it. So y over 2 greater than, I'm going to subtract the 2 across. Okay, so it goes to the other side and subtracts because it was adding. It goes to the opposite side, does the opposite. And then I need to get rid of this 2, so I'm going to multiply everything by 2 to get rid of that 2 off the bottom of the y. Because you always have to do inverses. So if I multiply by 2, that's 2x, and multiply by 2, that's a 4. There, that's y equals mx plus b form. Okay, so on this one, my line is going to be a dashed line because I don't have a little bar underneath it. So that's kind of good to know. My y-intercept is a -4. So -4 is my y-intercept. My slope is the 2, so it's 2 over 1. So I'm going to rise 2, run 1, rise 2, run 1. And keep doing that. And it is a dashed line that connects them. So lots of stuff I'm putting in there. And now the last step is to pick a dot and see if it works. I could do the 5, 1 again. We could just do that one again. That's kind of funny. 1, 2, 3, 4, 5, 1. Yeah. 5, 1 doesn't look like it's on the line. Let's plug it in and see if it works. So I'm going to plug in the 5, 1 here. So let's get rid of all this stuff. So plugging in the 5. So 2 times 5. All right, let's see. Is 1 greater than this? So 2 times 5 is 10. Subtract 4. Is 1 greater than, what, 6? Is 1 greater than 6? No. That is definitely not true. So, not true. Oh, you can't even see that. So, no, this is definitely not the case. Let me go right to my iPad so you don't see my face there. That is definitely not true. So, the dot I picked is wrong. So, that means the other side should be true. So, all the dots over here are the ones that work, not the side that I chose. Okay, so that's what we're doing in the activities this week. Again, thank you for all those who are actively participating each week. I always really appreciate it. You know, take care of yourself, stay healthy, stay safe, take care of your family. Again, all missing work, late work, redo assignments, grade changes, they're all due by Wednesday, I should say. So keep that in mind. So get on top of that, and I hope to see you guys real soon. Take care.